Okay, hello everyone. We're going to get started slowly. Well, people come back from lunch here and connect. Some of them very early in North America or a little late in Asia. So hi everyone, welcome to the IETF Madinas working group at IETF 113 here in Vienna, Austria. Our first hybrid meeting, and we see many more people in this for this session connected remote than locally. Yes, so for some of you, it's very early breakfast, and I'm glad you guys are joining. So uh, let's move on. First of all, the note well, as you know, this is an IETF meeting, and therefore all the IETF policies and procedures apply. So please be aware that participating in this meeting, you agree to these policies and procedures. Therefore, if you are aware of any IETF contribution covered by patent or patent application, please let us know. You have to disclose it or not participate in the discussion if you so desire. You acknowledge that written audio and video photo records of this meeting will be made public, and the personal information that you provide to the IETF will be handled in accordance to the privacy statement. We also ask you to please agree to respectfully treat other participants. We don't have any tolerance for harassment or any other bad behavior. So please, if you have any issues, you can contact the ombudsman for this matter. If you have any questions, you can look at the BCPs that are on the screen, where you will have more information about the procedures. So again, this is a hybrid meeting. Yeah, okay, no, sorry. And for in-person participants, make sure that you log into the Meeticle so that your presence is logged. We will also use the Meeticle to manage the queue. So if you want to comment or raise your voice, please join the queue by raising your hand, either remotely or in person, and we will manage the queue in order. For remote participants, please make sure that your audio and video are off unless you are sharing or, well, in this case, not sharing, but presenting. So if you have questions about the agenda, the meeting information, or you need technical assistance, you can also use those links. And final point, so minutes are taken, the meeting is recorded, and your presence is logged. So at this point, we would like to see if anyone could help us take notes. Laurent, thanks. Anyone else? Ivan, thank you very much. Much appreciated. For everyone, you can also contribute to the note taking in the CodeMD, and you have the link there, but very much appreciated. So the agenda for this time, we have these slides that we are going through right now. We're going to start with Jerome talking about the use cases and problem statement draft, randomized and changing MAC addresses, followed by Carlos presenting the MAC address randomization, current state of affairs. So those two drafts have been adopted by the working group, and they will be the main focus. Thereafter, we will have a presentation not by Bruno, but by Luther on the updates from WBA, sorry. Followed by Jerome also giving us some updates on IEEE 802, 11, BH, and BI. We will finish with the next steps. Are there any questions or comments regarding the agenda? Okay, so hearing none, we're going to move to the next slides. And give me 1 second. So I'm going to share slides, and Jerome, I'm going to, if you can unmute yourself, I'm going to pass you the control so that you can move the slides from your side.
All right. Thank you very much, and good afternoon, everyone. I'll say good afternoon because it's Vienna time, although it's morning for me too. So what I would like to do in this section is to give you an update on this use case document. If you are familiar with Madinas, you may remember that we've been discussing this document a lot. Um, the context of this document, let me share if I can change the slides, right, is that we've been trying to organize our thoughts around the idea of RCM and the use cases behind RCM and what it might be breaking. If you want to follow along, the document is at a link that is available at the top of the slide. And we realized that in many cases, the conversations where often people pass each other, and that's because there are multiple environmental constraints and variables that people were referring to, and they were not always referring to the same ones. For example, when we say they are spying on your personal information, your PII, they, who is they? What PII are we talking about? So in this document, we are try to organize the different use cases and different environments where RCM might be affected. So we start in this document by defining the device side by saying, well, there are different types of devices. And here we use the IEEE definitions and the ISO definition, where we recognize that there are personal devices, devices that typically belong to a small group of persons, and there are shared devices, that is to say, devices that are used by a large number of people, and whereby, of course, the activity of those devices is not necessarily reflective of activity of a single user on these devices. For example, a switch in an enterprise. And also we try to understand who are they, these different actors that may be involved in this exchange with the infrastructure and the internet, starting from the user device. So we recognize that there are some network entities, that is to say objects, for example, that is your Wi-Fi access point, your wireless LAN controller, your switches, your routers. All these devices may have a view of the device MAC address as traffic transit through them. But there are also some human-related entities, and that could be, multiple people. Of course, it could be the user, but that could be also the IT support in an enterprise. That could be the entity managing the Wi-Fi at your airport, etc. So each of these will have a different type of interaction with the device's information, and of course with the MAC address. We also recognize that not every environment is the same, and not every user has the same relationship with the environment. So we come to define what we call the trust level, where we say there are places where probably a device and its user will not trust any device or any actor in the environment. Typically, public Wi-Fi, guest Wi-Fi, you will not trust anything. There are some other environments where the trust might be more towards the partial trust, where you may be trusting some of these elements, but not all of them. For example, if you are in enterprise network with device provided by your enterprise, it is likely that you might be trusting the network, wire network section of the enterprise, because all that is managed, your device and the network. You may not trust, the air and people sniffing around, but you may be trusting, the services provided by the device, to the device by the environment, etc. And then we go on by listing the entities among all of those that may have a need or an interest in tracking MAC addresses. So that is, of course, anything that is a functional entity that needs the MAC address to proceed through communication exchanges. But of course, there are some entities which are human entities that rely on the MAC address for different purposes, like troubleshooting, tracking, or legal tracking, etc. So we list all these elements, and then we finish these documents by listing the assumptions. And again, I bring you back to the documents to list the assumptions about the fact that a network element should not rely on the idea that there's a unique MAC address association to a device that would be permanent, etc. So again, I'm just browsing through this draft fairly quickly because I know we've been discussing it extensively. In the current version of the draft, you may remember that before its adoption to the Madinas group, we had a conversation about this draft extensively. And the last one was in the meeting prior to the vote by which the group decided to adopt it. So after the vote to adopt this document was passed, we changed the name of the document and brought it from the Henry something version 3, if I recall, into the draft IETF Madinas use case version 0, which is the same document as this Henry v3 document, but brought into the ownership of the Madinas group. And then immediately after, we started implementing in V1 the comments that we received in the face-to-face where it was decided and voted that we would adopt this document. So currently the version that you will see in this document is version 1 of the Madinas use case document. And of course, as usual, this is a working document. So any feedback, any reading, and any comment is very welcome. This document, of course, is a living document. We're intending to work with it to improve it. And among the things that we think we could do, one of them is to match this document's evolution with the charter of the group. And that includes, for example, survey the current standards and their use of the MAC address as a device identifier in the protocol. We'll have a quick read in about half an hour, I think, on what happens at the IEEE in the 802.11 group, but it's likely that there are some other groups and other SDOs that could be interesting to us. Once we have this reading, it could be interesting for us also to come to conclusions on whether we see that the usage is conformant to what we think should be the right balance between operational efficiency and privacy. So we could also make some recommendations to the working groups, to remove those dependencies if there are any. Of course, we will likely identify that there are some scenarios where we will not want these devices to be identified by anything, in which case, rotation of MAC address is something that we'll be probably suggesting or recommending, and we'll be examining what protocols can be affected by the rotation of the MAC address. There will also be likely some scenarios or environments where we will identify that it might be useful for the user experience and for the continuity of service that that identifier would be exchanged between the device and the target service. In that case, we need to comb through the different standards and see if there are some identifiers that could be used that could be replacing what has been used today, which is the MAC address. And as we identify those mechanisms, we might be suggesting some existing mechanism. One that comes to mind, and that's the third bullet you see here, for example, being an 802.11 person, is that there could also be value to inform the station about what kind of environment it is in. For example, in 802.11, there's a table called Table 966, which is defined in the ANQP section of the document that defines venue. And it says, the access point can express what kind of venue this device is in, and it can say it's very expensive. It has more than 70 types of venues, from automotive to a boat to airport, etc. So that could be information that could, for example, be sent to the station to help the station assess if it may decide to start trusting some of the services or not, knowing that this information, of course, is not secured, it's not authenticated until the association is complete. So there are all sort of environmental conditions that we'll need to think about. But that kind of exchange of information between the venue elements related to services that the station may need and the station may help the station decide what to do and what kind of environments it might be operating, and therefore make choices in terms of obfuscating further its identity or revealing some identifier to some services that it decides needs to be continuous through the MAC rotation. So that could be an identity, of course, to the network or to specific services. And of course, in that same line, it could also be the idea of informing the service before the MAC address changes if we identify as we come through those standards that there is a dependency on the MAC address. So among all these steps, the first one to me is probably one where we have most urgency and a lot of work to do, because I'm an 802.11 person. My knowledge of the now close to 9,000 IETF RFCs is more limited. I don't know the 9,000 by heart. So it would be interesting for us to look into those standards, outside of the IETF, but also within IETF. to know which ones use the MAC address as a device identifier and possibly make the expectation that the device itself is identified by its MAC address. Few RFCs that come to mind would be those related to protocols like DHCP, for example. It seems to me that in the choreography, the initial identifier of the station as far as layer 3 goes is 000 if it's IPv4. And then, the address is going to be the MAC address to and from the DHCP server. And then once the IP address has been assigned and allocated and accepted by the station, it seems to me that most of the time the station is going to be identified in the DHCP server by its MAC address and its association to the IP address. So that could be a first, element that comes to mind. But again, I'm not an expert in these RFCs. Those of you on this call in this room have more expertise there and may help us identify those protocols and what kind of dependencies assumed or not assumed, and also are there some identifiers that could be replacing the MAC address in those. Another one, of course, is anything which relates to 802.11 process of attaching to an access point, and that include heap, that includes radius, and probably others. So if you know of any protocol or standards or RFCs where you think the MAC address may play a role in the identification of the device, I would like to call you to come forward and post to the list, or talk to us, help us identify those protocols so we can start in this draft listing them, and listing and documenting how they expect the MAC address to be used. And of course, this is true at the IETF. This is true, of course, elsewhere. The IEEE 802.11, we have some familiarity. I'm sure that I'm not going to be able to identify all by myself everything that is done in 802.11, for example, which is close to 6,000 pages so far. But there are also some other, SDOs, the IEEE itself, 802.1, for example, and of course 802.1x, all the association for radius, but also other SDOs like the WBA, for example, the Wi-Fi Alliance, and many others that I don't think of. So please, if you have any willingness to contribute, help us identify those. Please help us, by maybe listing how you see, documenting how you see those MAC addresses be used, or if it's just too much of a read, please just share RFC numbers, protocol numbers in the chat, in the list, and let's start together exchanging on those and come through the practice of the industry today to identify where MAC addresses are needed and see if we can continue operating services without those MAC addresses. Let me pause there to see if there are any questions or any comments.
Yes, we have Carlos in the queue.
Yeah, Carlos Bernardo's question as an individual, or a comment is on this point about the identifying what protocols use the MAC address as an identifier. I wonder if there is any way of where we can do this as a more, I don't know how to say, a way that we ensure we don't miss any, because I guess there will be many potential protocols out there that may use the MAC address the MAC address as an identifier. I just thinking of, for example, mobility protocols. There are a lot that come to my mind that MAC address may be one of the identifiers that they can use. It's not the only one, but maybe. So I wonder if there is anything that we can do to make this in a more organized way, maybe asking feedback from other working groups. I don't know how to do it to ensure that we don't miss any. Because I don't know if this bottom-up approach we may miss some. I don't know. This is a question for us to think about.
Yes, thank you very much, Carlos. And in fact, I think we should do both. You're right. I think a liaison and if we have such things or questions to the other SDOs would be a great way to help us. I did a fun exercise the other day. I went to DuckDuckGo and searched for MAC address with the site ietf.org. I found only 200,000 references. So just that tells me that it probably would be useful, even within the IETF, to maybe query experts in some groups or the groups themselves, if we have such communication medium, to ask them to help us. So yeah, working both way up, bottom up, and top down. Yeah, thank you.
Okay, thank you.
I saw someone else approaching the mic, but I'm not sure.
Yeah, well, we have people here in the queue, on the virtual queue. That's how we will
All right.
manage it now. So
Okay, great.
next in line is Bob Moskovich.
Moskowitz here, and I am the pretty much the lead technical contributor to the DRIP working group, and where we're dealing with unmanned aircraft. And right now we're focusing on what's called the broadcast remote ID. These are messages which are sent with broadcast frames to receive by observers on the ground. So these are sent through the various broadcast frames in Bluetooth 4, Bluetooth 5, or Wi-Fi, NAN, or Wi-Fi beacons. The observer can only see these messages maybe for a brief period of time to need to link them together. This standard has been written and designed to use MAC addresses, particularly Bluetooth 4, where we only have 27 bytes of payload. So anything to do has to be linked via MAC addresses. In terms of the UAs themselves, they pretty much are consistent on at least using the same MAC address per quote operation, which you would call per flight. The problem, of course, comes that some of the clients, particularly Apple, randomizes the MAC address that they intercept to feed up to the application. So the application won't know it's really sent. And that breaks the application severely, where the application needs to know what those MAC addresses are to be able to link the stream of messages together while that UA is observable overhead. So this is particularly a challenge in this one particular use case, which considering what the rollout for unmanned aircraft is expected over the next 10 years, is really an important use case.
Thank you, Rob. Bob, yeah, I think this is interesting case, and I'm fairly convinced it's a side effect that was not envisioned by the vendor you you named. Would you mind posting references to this standard to the reflector? I would be very interested to start looking into documenting
Yes,
it.
I don't think I'm on Madinas right now. So like I said, I've been remiss this past period of time not getting active. And you gentlemen know me from various places, so I will step up my game and get active here with you. And Adam Whitaker is also on this session, who's one of my co-authors, and we'll start pitching in here to make sure that it's covered in your work, because we are limited with remote ID and what we can do and how long that UA may be visible in your airspace.
Yeah, indeed. All right, thank you. Much appreciated. Thank you.
Thanks, Bob.
Okay, thank you.
Next in line is Tim.
Hey, Tim Pelly. Hey, Jerome. So on the, I'm not sure about all the tooling across the SDOs, but at a minimum, I think we should be able to dereference the MAC address, right? If people did normally dereference it and pull all the specs that mentioned it. I mean, I don't know, that might be an easy way to get a bunch. On the use cases, looks awesome. The one thing I would say is across these docs, I would avoid MDM versus BYOD. I would say managed and unmanaged. Just there's too much ambiguity, and it means different things to different people. Managed is very concrete.
Yeah, thank you very much, Tim. Yeah, well taken. Yeah, I'll make the change.
Thank you very much, Tim. Next is Michael.
Hi, I don't get I don't get any Wi-Fi in this room right now, so it's kind of hard to get in the queue. Michael Richardson, the mic. So what is the point of dereferencing all these uses? I'm not sure that there's any, like, I don't know what the cost of missing a protocol is in this, because I don't know what we're going to do with this list at the end of the day, and I think that's actually more important discussion to have than how to get, all the references, is what is the goal of doing this? And I think Bob actually brings up actually the more important point. Apple is removing those MAC addresses so that nefarious apps can't, watch where you are and what's going on. And yet, okay, that's for your own privacy benefit. And yet, Bob is writing an application whose purpose is to find out who's spying on you with their drone, right? Which is clearly a much bigger privacy impact than the other part. So I think what I think we're doing in this group, I think we're going to be trying to write down the set of compromises where randomized and changing MAC address is a good idea, and where it's a bad idea. And then, in fact, it may be privacy violating to do that rather than. So I don't think our goal should be, how can we remove MAC addresses from being the primary key of databases everywhere? But rather to say, these uses are clearly privacy violating, and you should do something else. And these other uses are going to have to, the second category, well, you're going to have to do some correlation after the fact. And the third category is, my refrigerator just isn't going anywhere. I really don't care what MAC address it uses. It's always going to be in my house, and it's not going to Starbucks, and that's really it, right? It's a moot point. At the same time, I really need to know my MAC address of my fridge because I'm pretty sure it's never getting a software update, and I need to defend it. Okay?
Yeah, I'd like to, well, answer just to your point about the purpose, because I think that touches on the group's chart there. And I think indeed what you mentioned is the end goal. So it's not to say let's randomize, but rather, given the fact that randomizing MAC addresses is happening, we want to list all these use cases, and you just went through a few of them that are very relevant. We want to make sure that we capture in this document all these use cases plus any other that people may have. We talked about the hospitality or private networks, public networks, etc. So fair enough. And then once we categorize those, we can say, yes, in this case, it doesn't make sense. In this case, it makes sense to identify the device because we want to obtain a service and the user is willing to do it so that he can get the service. And then, yes, now, if we do want to identify the device, is MAC address the right identifier? Or is there any other identifier? Or is there a protocol there that no one has looked at, or another protocol that is actually being deployed right now? I think that is the purpose. And if at the end of the day we realize everything is fine, we can just point to those solutions. If we find out that there is more work to do, yes, then I think we can raise the question, what do we do? Okay, so I interjected the queue, sorry about that, but if there are no more questions, we can move to the next presenter. So thank you very much, Jerome. Don't go up too far.
Okay, I think now it's better. So I'm Carlos Bernardos. I'm presenting the MAC address randomization draft on behalf of my co-authors, Juan Carlos Zúñiga and Amelia. So just a brief introduction, because the goal of the presentation today is more about talking about next steps and specifically about some changes, potential changes on the table of contents. But well, some introduction, you all know, privacy is an increasing concern, and the use of MAC address, unique MAC address, may lead to some potential threats. And because of that, well, many projects and many OS vendors have started to randomize addresses. And that also triggers some other efforts in some research and standardization communities about the use of MAC address randomization. And this draft is basically documenting what is being done in those areas, in those SDOs, and also in those mobile OSs what are the policies and approaches that are being used to randomize MAC addresses. So this is the current table of content of the draft. We have the introduction, the background, the activities on the IEEE, on the IETF, on the WBA, and then we have a section on the current practices of the different OSs, focusing a bit more on the mobile OSs, but also covering other fixed OSs. And that's the section I will have a question at the end on how we basically manage that particular section because we got quite comments on the mailing list on this. So moving on. In IETF, well, there's been quite a lot of activity related to MAC address randomization. We started quite in IETF 91. We were doing some tests, some experiments. For those that were there, maybe you even tried the scripts that we provided to see what happened when you started randomizing addresses in a real network. There were also other documents related to privacy, the use of different IAVs and IPv6 and other things in DCP, the potential impact of using an identifier in the protocol. And then after that, well, it came that now randomizing MAC address is the default policy in mobile OSs. And well, there will be more on that at the end. Oops. Let's see. That's weird. Well, anyway, there are some activities also at the IEEE. I don't know if you stop and start, that gets fixed. Anyway, you will see later on this by Jerome. So basically, here's just a pointer on what Jerome is gonna be explaining later on. And then I don't know, there is also a section in the draft about the WBA activity. The Wireless Random Alliance look at the issues created by randomizing MAC addresses. And there is a document documenting the use cases where this is relevant, where this may cause some issues. And Luther, I think, is going to present that next, right? From the WBA. Then the current practices. This is an excerpt from the draft about what the major mobile OSs are doing today. Android starting from version 10 and iOS from version 14. I will not go into the details, but basically we look into how the randomized MAC addresses are created, under which circumstances, and when they are refreshed, whether they are persistent or not persistent, whether they change from one network to the other, or they rotate through maybe every day or every sometime, these kind of things. And we also did a more elaborated tests involving also Windows 10 and Linux. And in the latest version of the draft, we also added some notes that starting in Android 12, there are some changes compared to what we did in the previous version in terms of the use of persistent or non-persistent address randomization. So there are some few changes, some few tweaks there. Regarding the updates, version 00, IETF 00 was exactly the same version that was adopted, the one that was in the working group adoption call. And in the current version 01, we basically address some comments that we received mainly from Hey Salom on this Android particular change. Next steps, well, of course, we want to have more feedback. We got already some feedback, and reviews and comments are very much welcome. And then we have a key question for the working group to address. That is how we tackle the feedback about section 7, these OS current practices. There were some comments on how to basically keep this section up to date, whether we should move it on a wiki or some external repository somehow that can be updated even when this document is published. So there are some options listed here. There may be others, but the three main ones that we see is, one option is we keep it as it is. Option 2 is we move current section 7 to an annex and refer also to an external wiki or other type of URL or document repository where we keep that text updated, but we still keep like the picture of what is the status at the time of publishing this document. Option 3 is we convert that section 7 in the external reference, so there is no current picture kind of or snapshot of the status in the document, and we refer to some external resource. And there may be other options. So this is the main feedback that we are requesting to the working group to consider for the next updates, in addition to, of course, any other comment that you may have. So please state any opinion on this now or on the mailing list. We will appreciate feedback on this point.
Thanks, Carlos. So I'm putting myself in the queue. I personally have a preference for not option 1, definitely. And between option 2 and 3, I think it depends on what is going to be the actual goal of the document. I like the idea of keeping it dynamic personally. And if we are not going to draw any conclusion from this draft and it's 100% informational, I think it makes sense to keep it completely outside and then rather concentrate on how we can keep that wiki up to date. The document, I think, makes a very good background that explains people what we're doing and how we're doing it and what is happening anywhere else in the SDOs. But for this specific point, especially because it will change so much in time, I can see that it'll change a few times from now until we publish. So I think it'll diminish the value of the published document if we take snapshots. So my preference would be to keep it completely outside and point to it.
Okay, I'm fine either way. I agree that option 1 is probably the one that we can discard right now, and then option 3 to make sense. The question I have, personal question I have, that is also for feedback from the community, is how is the best way, what is the best hosting for this type of information? When we talk about a wiki, where that wiki should be hosted and these kind of things. I don't know if there is previous experience in IETF on doing this in documents, but that will be appreciated to know.
Yeah, that's more a procedural thing, but it's true that it'll be useful. Do you have a comment about this, Eric, or you will go through the list, the queue, sorry?
No. I'm going into the queue simply to say what I've seen in other working group. They're using GitHub for the main document, and that this living document in the GitHub under the IETF repo to ensure a long-term lifetime.
Okay, so if I get it right, the idea will be to in the GitHub put that information, right? That like a version with this there. Okay, thanks.
Okay, thanks. No, we have one more question, sorry, from Matthew.
Matthew Camp speaking. Just a comment regarding the table you've just presented, where you list the operating system. We already discussed about this issue, but so I understand that for iOS and Windows, it's rather a monolithic system, but for Android and Linux, they are based on components. In fact, it's not the Android system that decides how the address is handled. This is a component called the WPA supplicant, and maybe it's not the only one that is dealing with that. And the features that can be implemented in the code and also activated by Android and also the vendors are such that the way address normalization may vary a lot between the same version of Android, depending on how the vendors decided to activate or not some of the features. So my question is, maybe we should, I don't know, but mention that it's not Android per se that is doing that, but refer to the version of the underlying software components that is managing those randomizations.
Okay, that's a good point. Regarding Android, from what I understood, I mean, in Linux, I fully agree. Linux, there are many options and you can configure everything and depends on the distribution that you may have and the network. If you are using Network Manager, there are like at least 3 options or 4 options regarding this that you can configure. So it's really on the user. And then if you go more low level, touching the WPA applicant, then you can even have more options. So in Linux, it's true that it's more user-driven and there may be variations. We try to capture in the document, but we may try to improve that, the options. So depending on how you configure things, what you can get. That's for the Linux part. For the Android, I also agree. There, I think that what we tried to put there, or what we put there, is basically the official vanilla kind of Android approach. But I guess I'm not an expert on that. It's true that then the user and the variations that the vendors of the mobile phones, these customizations that they do, may change the behavior. So I guess we should also try to say, okay, this is kind of the baseline, and these are the options or the different things, the different behaviors that you can also obtain using an Android or any other OS.
Okay. Could you make your point in 30 seconds?
Yeah. I would just ask Kai. There's a certain designation that can be given to an Android device if it's certified, and that might be worth the call out because you have to meet a certain criteria. I think it's GMS certification. So.
Okay. Thank you very much. So now we're moving to Luther. And I'm going to pass you the control.
Thank you. So thank you for letting me present on behalf of the WBA. What I'd like to do is cover what has transpired since the last time that we spoke in front of this group. So just as a quick summary, let me see how you
Underneath.
got it advanced. Yep, got it. So when the group was developed or put together, we had the scope of generating a white paper, which consisted of defining use cases, identifying how the Mac was used within these cases, with which was either required or a need to have. We sought out and identified different methods that have made use of the MAC address and how they need to be addressed to replace the use of the MAC address. In that, we took all the different current solutions, we analyzed them, and we documented them in different facets and against the different use cases. And then we created a section of recommendations and how these solutions may be used. Then what we did was we examined the gaps between these solutions where they did not meet the requirements to solve the problem or address the problem of RCM. And then we put together a solution, suggested solutions for the different use cases. And finally, we are now in the process of liaising the completed paper out to other standards bodies. So just a quick timeline of the work group. We started it just over a year ago. We initially identified the use cases we're going to look at. At that time, we did liaise those over to the group. As you've heard, that it has been shared with this group. Then we moved into the next part of discovering and analyzing the different solutions that we had identified, how they could be applied to the different use cases to address the RCM. And just less than a couple weeks ago, we finalized that paper, and at the beginning of this month, we started the process of liaising the paper over to this group so they can make use of it as a reference. So within the paper, there was many findings that we have, and we have wrapped those up, which includes the need of identifying the device or the user and identifying that up to the higher layers. Earlier you heard, I think it was Bob or the individual talking about the unmanned aircraft, how that, that's a prime example of where the MAC address or some sort of identification needs to move to upper level functions. And there is cases where we don't need to just identify the device, but link that device to a particular user, and how that is done. We did identify that it was paramount that the device and the user maintain its privacy, that it cannot be or should not be able to be sniffed or tracked, so that the user can traverse across different venues, or move around without the indication of being tracked, or just identifying where they're making use of different data. So we did look at it that over years, as we know, the MAC address has been used by different functions, different networks, different individuals for many different aspects. And while the MAC address was not set up for this use, it was an easy indicator to identify a device for different functions, such as access control, being able to troubleshoot, and also even within law enforcement, that this is something that is needed, that we need to be able to at least identify the device somehow or other in order to maintain these functionalities. In looking at the different technologies that are out there, we also looked at how they attempt to identify the device, either directly or through the user to identify the device. And that this is how we can do it, how we could take these solutions and apply them to the various use cases. So as we were looking at this and talking to different vendors, we found out that in the majority of cases, the current RCM implementation is session-based or a time-based, that they will maintain that same MAC address. But once a session has ended and that SSID or network has been forgotten, it comes back generally with a new SSI or a new MAC address. However, there is some applications where even during the session, and if the network has not been forgotten, over a period of time, the MAC address is reset. And this impacts, like I said, the earlier conditions, such as troubleshooting, access control. One prime example is, you visit a hotel, you go through a captive portal, you go out for several hours or a day, and you come back. Now you have to go through that process again because your MAC address has changed. So it becomes a very repetitive, reduces the user experience. Based on that, as indicated above, privacy is paramount. So with the RCM, it does ensure address privacy or device privacy, and it helps prevent tracking as well as snooping or interfering or putting out a rogue device that could mirror a actual device that is connecting. So in this, while we were looking at the different solutions, one thing we found that was very key is there is no one set solution that solves it all. It's not a single solution to blanket all use cases, but that a set of solutions could be used to cover most of the use cases. However, that some of these solutions actually will conflict with each other, so they can't be used in harmony. And this wraps up all the basic findings that we found. These findings are listed out in the white paper. As I mentioned earlier, the WBA is in the process of completing the liaison to make the paper available to this group. There is plans that this paper to be published publicly, but that is probably about 3 months out. So with that, and closing, is there any questions?
Thank you very much, Luther. I put myself in the queue. First of all, we very much appreciate the report from WBA. I think it's extremely useful and relevant. And I just want to clarify, as you mentioned, that we very much like the fact that you are communicating with us this white paper. The information is very useful and relevant, and we are, as you know, we are just clearing out the way to make sure that it's shared properly. But with that in mind, I think that this paper is extremely relevant and useful reference for our use cases. So of course, not only managed networks, we are going to look at all type of networks, but we have to make sure that all the use cases that you mentioned are covered. Perhaps there are some that fall outside your scope, and that would be fine. But for the ones that do fall in your scope, we don't want to reinvent the wheel. So having access to this white paper so that it can be either referenced or I don't know if the information can be just referenced and copied or simply, it will depend on whether the document is public or not, I guess. But once we have that information, we can revisit, I guess, the Jerome's draft on the use cases and go back to the drawing board and see if these solutions that you mentioned map to the ones that we are identifying and move forward. As you know, the purpose of this group is to find the gaps and then ideally point to solutions. If you are already doing that and you found some issues, that's perfect. If those issues fall in the scope of IETF, then it'll be the next topic for Madinas to see how we can do that, if we have to talk to the relevant working group or if we have to do some new work, etc. So thank you.
Yeah, it was interesting looking at where the gaps were based on solutions that were currently out there and how they apply to the use cases. Thank you very much.
Okay. Excellent. Thank you. So now we are moving to Jerome. And sorry, Jerome, you'll have to give a quick update of the latest and greatest from IEEE because we're running a little late.
Yep, no worries at all. Anyway, it's going to be a recap of what we've heard before. You know that at the IEEE there are multiple groups. The one I'm going to focus on is the 802 group, the networking group. And we mentioned before there was a group called 802E, which brings recommendations for privacy in consideration in the development of 802 standards. So I want to mention this one because maybe this is one of those where we will want to have a look to. But the main two I would like to focus on are the 802.11bh and bi, where many of you have heard of. So they were formed at the end of a group of study of privacy and the effect of RCM in 802.11 standards. And they have two different objectives, and I will give you an update on what they are. BH is a short-term, at the scale of the IEEE group. Its goal is to say vendors like Apple, as some mentioned that, but some others as well, are randomizing MAC addresses. What is the effect on 802.11 services? So sorry, I forgot to mention that RCM is randomized and changing MAC address. So RCM randomized and changing MAC address. So given that devices randomize and change their MAC address, what is the effect on 802.11 service? And is there something that needs to be done in the IEEE 802.11 group to address the effect of those MAC address changes? The idea in this group is that the 802.11 standard does not allow a station to change its MAC address while in session. So you can change your MAC address between connections, but not within a connection as of today. But changing between sessions can have some effects like troubleshooting. You have a problem with your phone connected to Wi-Fi in the enterprise today. You call support tomorrow morning and they don't know who you are because the MAC address has changed. So that's the kind of thing they are looking into. In the current status of the group, they identified of course, that multiple things may be broken by RCM, and they have identified 9 solutions, which essentially are about trying to pass an identifier between the station and the access point, so that if the station changes its MAC address from one day to the other, from one session to the other, etc., it can come back and re-express an identifier back to the AP. And essentially, in these 9 proposals, some suggest that the AP gives an identifier, then the station comes back and decides to re-express that identifier if it wants to be still identified, or doesn't do it if it doesn't want to be identified the next time. Some others say, well, no, it's the station that's going to express an identifier, and if it wants to be identified again the next time, then within the secure connection to the access point, it's going to re-express the same identifier. And some others say, well, no, it has to be a sort of combined agreement between the two, where they express a sort of algorithm, for example, which means that as the station changes its MAC address, the AP can process a computation that recognizes that the next identifier is the same as the one before. So that is the status of where BH is. They are a little bit late. They were planning to have a text by this March. They don't have it yet. They're still discussing which of these solutions should be adopted and how, etc. But their target is short. They express the intent to be finished by the end of next year. And there's another group which is longer term, which is BI. And what these people do is that they look at 802.11 and try to identify if there is a way to augment the privacy of devices within 802.11. It's obvious that anybody can sniff the network. So they want to see if there are some identifiers sent in 802.11 frames that could expose, the uniquely the identity of a device, beyond the MAC address being just one of them. And of course, they identified tons of them. So for now, they are going through combing the standards, and they have tried to make requirements on what exactly should be protected and against what. So that's interesting work for us to look at. And of course, their approach is very much focused on these first 2 layers, the PHY and the MAC layer. So they identify what most of us know, right? That there are some keys that you exchange for which you make an identification by saying, I'm reusing key number 55 when you rejoin. Well, if we identify the key, then we may identify the station because that's the station that was using key 55 before. There is MAC address exposure. You have a header which has a lot of options, many of which allow to uniquely identify a flow or the station. So they are listing all these exposures that they call requirements, that they think should be obfuscated at this stage. They should finish by this summer-ish. Once they have that, they'll start looking into 802.11 and start looking into what they should do, what text should be brought into the standard to alleviate those exposure. So those two, for us are probably interesting to look into. BH, not so much, because I think we'll find items for us to refer to because they are looking at short fixes on the IDs to pass an identifier. But it's interesting for us to realize where this identifier is scoped to be limited to. And it's really between the station and the access point. So as we progress in our work, it will be interesting to see if we can use that identifier or not. BI is also interesting, but at another level, to look at what kind of exposure we have beyond the MAC address, which can be used maybe for us to as an inspiration or example to look into what kind of exposure we may have beyond the MAC address when we talk between station and services in this group, if we decide to go there. So you'll find here, these documents. The 802.11 is very open. So if you go to the second link, you can access pretty much any public documents in the working group, presentations, contributions, etc. The only thing you cannot access is the draft, really, of the next standard. But you don't need that. We don't have any at that stage yet. Let me end there so that I don't take too much of my time and check if there are short questions before we move on.
Okay. Thank you very much, Jerome. Are there any questions before moving to the next steps? We are at the top of the hour, a minute. If there are no questions, I would first thank you for the updates and the presentations. Thank you very much. And I think this is great to see that, at least to me, it looks like we have all the pieces of the puzzle. We have the input from WBA. We know what's happening in IEEE. We are starting to identify the relevant use cases, and it's just a matter of putting all the pieces together now so that we have the full picture of what are the needs, what are the solutions, and move on to identify the actual gaps for the whatever use case or user, if there are any. So seems like we have an interesting and limited work to do, which is also in line with the short-lived task groups that you mentioned, and this one itself. So perfect. Seems to me that we have some interesting homework to do from now till the summer at least. And well, we are at the top of the hour, 1 minute over, in fact. So if there are no more questions, I encourage you to participate in the list. As you know, we will be hearing more information from WBA about the use cases. Once that it's cleared, it will for sure be distributed on the list. And that's it. So thank you very much, everyone, for your participation, and have a nice end of the day. Good. Thanks a lot.